Section 9.1, functions of several variables. So our definition, if we have a function of two or more variables, we're going to use this expression, z equals f of x comma y, if we have two variables. So we would say that x and y are the independent variables, and then z is the dependent variable, since it will change. So here the domain is the set of all real numbers, x comma y, and then the range is the set of all values for f of x comma y. Now the first thing we'd like to do is just to evaluate a function that has two variables. So here I've got f of x comma y is 4x squared plus 2xy plus 3 over y. And let's start by finding f of 1 comma 3. As per usual, the first number is our x, the second is our y. So let's plug in accordingly. X is -1, and y is 3. And then evaluating from there, -1 quantity squared is 1, so that's a 4. I've got 2 times -1 times 3 is going to be -6, and 3 over 3 is 1. So as my final answer here, I get -1. Let's use the same function, and now do f of 2 comma 1. So once again, let's plug in the 2 for x, and the 1 for y. And these are both nice, because I'm going to be able to get rid of that fraction for both of them. 2 squared is 4, times 4 is 16, 2 times 2 is 4, and 3 over 1 is 3. So here I'm going to get 23. And that is the first thing we will need to be able to do in this section, is just to evaluate these functions. The next thing we'd like to look at is graphing planes. Our general equation here is ax plus by plus cz equals d, where a, b, and c are our variables. And as long as a, b, and c are not all 0, we will get some sort of plane. Now, when we draw 3D on a 2D graph, we're going to draw like that. So z is the axis that goes up and down. You'll notice I write z with a little cross through it, so you can tell it's not a 2. Y is the one that's going left and right, and this diagonal one is our x. We're imagining that this is the one that comes out of our paper. Since we can't actually draw it that way, we're going to just draw it at an angle. So for each of these, as you might recall, when we first graphed lines, we usually picked a random value for x, and then found the corresponding y, or vice versa. We're going to do something similar here, except we'll pick values for 2 of the variables. So let's start by picking x is 0 and y is 0. We try to pick 0 whenever we can because it's easy. At which point I get z is 6. Now I'm going to write what we call an ordered triple, so it goes x comma y comma z. So here, to graph that, I'm not going anywhere on the x and the y. I'm just going to go up 6 on the z, and it'll be about there. Let's try now. X is 0 and z is 0. That's going to get me y is 6. So that's the point 0, comma 6, comma 0. So that's along the y-axis. 1, 2, 3, 4, 5, 6. I should have drawn my axis a little bit longer. And finally, let's have y equals 0 and z equals 0. And that's going to get me 2x is 6. So I get that x is 3. So 3, comma 0, comma 0 is going to be about there. Now you might remember for lines, we said all you really need to make a line is 2 points. Well, all you really need in order to make a plane is 3 points. So I'm going to connect the dots with straight lines. It looks like a triangle. Now we say this is just the first octant of the plane. It does continue, but as far as graphing by hand on a 3D graph, or on a 2D paper I should say, that's about as good as we're going to get. When you look at these on the homework or in the textbook, they're going to shade that in. So let me shade in here with a different color, just so we can kind of see. There's my graph. Let's try graphing one more plane. Now, you'll notice this one, I don't have a y value. Well, we know that there are special cases with normal lines. So what happens when we have a plane? So let's start once again with x is 0 and y is 0. And of course, there's no y in my equation, so I am just going to get z equals 6, and I get the ordered triple 0, 0, 6. Let's let x equal 0 and z equal 0, at which point I've got a bit of a problem. We're going to cross that out. We'll come back to get an additional third point later. Well, what if we have y is 0 and z is 0? Well, that's going to give me an actual value. That gives me x is 6. All right, let's start by graphing those 2 points. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. I'm going to draw a little smaller this time so I have room. Now, I don't quite have enough because I've only got 2 points. Let's try building off of this one. I'm going to keep x as 0, but now let's let y equal 1. Now, there's no y in my equation, so I'm still going to get z equals 6. So the x value and the z value are the same as my first point, but now I've got a y value of 1. So I'm going to take this point and shift it over here to give me a third point. So what I'm going to do is I'm going to draw a straight flat line through this point, and we could similarly get a straight flat line through that point. So this is a special case. I'm going to extend it in both directions, where I've got a plane like this. Again, I can't make that nice third point because I don't have a y value. That y value is not going to come in at any point. I don't cross the y-axis. So that is more or less how to graph a plane on a 2D piece of paper. Now we are going to look briefly at what happens if we've got something a little bit more exciting. So here I've got z equals x squared plus y squared. So this is not just going to be a triangle. This is going to be a little bit more involved. Let's draw an axis. Now, if y equals 0, I'm going to get z equals x squared. Well, that's a parabola. If x equals 0, similarly, I've still got a parabola, except it's on the y-axis. So basically, if I ignore the x, I've got a parabola. If I ignore the y, this parabola is technically coming out. I'm going to kind of draw it at an angle here, just because that's about as good as I can do with a 2D graph. What if z equals 0? If I get 0 equals x squared plus y squared, this is basically a circle. That's a point, but as z gets higher, I'm going to get a circle with a bigger and bigger radius. So I've got my point here. I'm going to have a circle here, a circle here, a circle here. Now, I'm not very good at drawing 3D graphs, but that is roughly what I'm trying to sketch. Let's go ahead and pull up a better picture, which is computer generated. So there's my rough sketch, and here is a better version. So think of this as a parabola that we are taking and we are turning around. It looks a little bit like a cone, except of course it doesn't come to a point. We call this a paraboloid. Our general equation is z equals x squared plus y squared. And notice that we're describing each of the 2 individual axes. So again, with just x and y, we're going to get points. With just y and z, we get a parabola. With just x and z, we get a parabola. Now we've got a couple of basic shapes. So the first is that paraboloid. We then also have an ellipsoid. Looks a little bit like a football, except of course it doesn't have sharp ends there. Essentially, we've got an ellipse on each of our 3 axes. An ellipse is in a circle where the two axes are not necessarily the same. So each option there is an ellipse. You'll notice we've got x squared plus y squared plus z squared, a variety of denominators. The big thing we want to notice is it's all added. Our next option is, this is a fun word to say, hyperbolic paraboloid. We sometimes call this a saddle. If you've ever seen a saddle that would be used for a horse, it looks a little bit like a horse's saddle. The big difference between this and the regular paraboloid is that one had x squared plus y squared. This one is x squared minus y squared. So I've got two intersecting lines there in the middle instead of a point. And the fourth option we're going to look at here is a hyperboloid of two sheets. It almost looks like we've got two separate cones. Again, they're not cones because they don't come to a sharp point, but that's vaguely what this looks like. What I want you to notice is they're all squared. Two of them are negatives, and one of them is positive. And that's what makes that hyperboloid shape. Now, probably the easiest way to figure out which of these is which is either by looking at characteristics of the equation, but you could also try graphing a few points. Now, we're not going to make you graph these by hand, since, again, drawing these by hand is pretty difficult, but you will see multiple choice questions where you're given an equation and then you have to take a graph. So we will see a few homework questions like that. And that is everything in section 9.1.